Hello, welcome to a creative channel. So today this is the third session, and we'll discuss about how to create a PLC program using ladder language. So we will not create a project again because you already learned in previous session how to create a project in GIA portal. So I've already opened the created project here and name as a session 3. So, in your project, as we already discussed in previous session, there is a program block folder and there is a main OB. So, main OB is an organization block where your whole program will run continuously. It will scan the input from the field and will update in input memory. Then, according to your logic, it will execute your program and update the output memory and you get your final output. So this whole cycle requires some time, that's called the machine cycle time. So the whole cycle will run in main OB and main OB have least priority. So those priority and the interrupt we'll discuss in the next session. But today we will learn how to write a PLC program. So before that, we must know the addresses fundamentals of PLC program. So for that, we'll open our device and network view. So in that device network view, you will see your project PLC. Just double click on it and you will get the expanded view of your PLC hardware. Go to its property in the inspector window. You will see the property option and inside the property there is a DI14 DP14, which means this PLC SO1200 having 14 digital input on board and 10 digital output on board. So you will get the IO addresses in the Siemens PLC. The IO addresses in the form of byte, means first starting from the 0 bit to bit number 7 and then next address will start from the byte 1. Okay, so I'll just show you. Find. So you can see the start address of your PLC input is 0.0. With 0 indicate the byte. Let me explain in the pin. So this is your age of memory. Okay, to hand and starting from the 0. This is your byte address. Okay, this is your byte address and this is your bit address. It will start from the 0, 1, 2, 4, 5, 6, 7. And the next line will be your byte 1, 2, 3. So this whole addressing will divide in the byte. So this byte 0, so first input will start from the byte 0. You can change anywhere like byte 1, 2, 3. But your address will start from the byte. I indicate for the input address. Next is your byte, which is your byte number, then point, then your bit address. So you are accessing this input. Okay, you are accessing this input, which is I For the input 0.0. Same for the output. The starting alphabet is Q 0.0, and it will be 0. Up to 0.7 for the first byte, and for next address will start from the 1.0, and so on. Okay, so this particularly we are using I for the input in the Siemens PLC, Q output Q for the output in Siemens PLC, but these addresses will be different by manufacturer, so you have to refer the manual. Okay, so again come back to here. So we have mentioned I am using byte 0 for the starting address, so my first address will be 0.0, my first input, and this PLC having 14 digital input, so the address will start from 0.0 to 1. How much? 1.5, because 14 input having maximum 1.5. Same for the output, it start from 0 and it's having 10 output, so it will end at 0.0 to 0.7, which will cover the 8 input, and the next will be 0. It's Q 1.0 to 1.1. Okay, so it's having 10 output. So we got our addresses. To create a program, first we'll create the program which having one input and one output. So what you have to do, once the input comes, my output will should glow, and once that input goes off, my output should off. So for that, whenever you creating the program, first make sure develop a PLC tag table for your program. So inside your project there is a PLC tag, and we'll create a one new tag table called the tag table 1. You can rename by F2. This is my session 3. You can give any name, but please make practice to give a standard name, so later on you can identify that this tag is belong to this tag table. Okay, it will be easy for you. Now double click on that, you will get one table format here. So I will assign my input name which is switch 1. Okay, and the data type, because switch is a boolean, so I will mention it as a bool, and my starting address will be I 0.0, my first input. So this option like writable or accessible from the HMI, so we will discuss this lecture, this options in next session or in next course card or HMI. Okay, so this is not useful in the PLC program right now, and our output is lamp. I'm saying it's a lamp 1 bool, but address will be percentage Q 0.0. Now the address tag table is showing me the yellow color, because yellow means the address is already used by the another tag. So we have to find that this project contain already these addresses. Okay, so I have to find my all show all tag table. You will get all the tag tables from all your tag tables, project tag tables. So show all table contain the all tags from all the tag table. So here you can see that I already designed the 3 tags which having I 0.0, 0.1, 0.0 addresses. So I'll delete those tags I don't require in this project. Now you can see the yellow mark has gone. Okay, so this is the very useful function by TIA portal. It's giving the notification to user or programmer like you are using this tag repeatedly, so it will avoid mistake. Okay, so we have designed tag table. Now we'll go to our main OP organization block and we'll create our first network. If you are not able to find this network, you can add by this shortcut insert network. Okay, as many as you can. And also you can delete by this option. any extra network. So I require only one network, so I'm using one network. Here there is a comment for your network. So this program output one logic. Okay, so it will be easy to read. So I'm using no contact. This is the normally open contact. It will scan whether my input is 1 or not. Okay, so I'm using this contact, which is called the normally open contact, and another is normally closed contact. Okay, this contacts you can get from the instruction palette on the right side. In the bit logic operation, you will get all these instructions here. This is the shortcut instructions you already provided by the TI portal. You can add and replace this instruction. Okay, so I am using these instructions. First, I want to just when my input is on, my output should get on. So this is vertical line act as your power supply. So as you know the electrical wiring, basic electrical funda. So when this supply line will pass to this point, you will get the output. Okay. So to pass this point, I'm deleting this extra contact. To pass this coil, pass this point, you have to apply here NC contact. Okay. So that's why I'm using here open switch. So when my switch will close, I'll get power supply from this vertical line to here. Okay, and I'm attaching the coil here, coil which is used for the output. So I'm attaching coil here. So when this switch is on, your power supply will flow from here to here. We'll see in simulation. Okay, so I'm giving the address here. So every contact should have address. So I'm assigning the address I0.0. Okay, or switch 1. We already mentioned this tag in our tag table. Okay, and this is my lamp 1. You can directly write the name also. You will get the solution list below. Okay, so now your program is completed. We will verify using compiler. This is your compiler. Will compile the syntax error. So very good. You don't have any error or warning. Now I have to simulate that my program is correct or not. So we don't have right now actual PLC with hand. So what we'll do, we'll use the nice functionality provided by TI portal, which is called the PLC Simulator. You can simulate your device as much as physical. Okay, so we'll open our PLC Simulator, which is 15.1 because we are using 15.1 TI portal. So choose accordingly. You can download from your Siemens website. Okay, if you don't know, you can comment in this video. I will provide the link. Okay, double click on it and your PLC simulator will open here. Just expand this view. Okay, it will take some time and you will get the expanded view of your simulator. So this PLC right now have no project, so we'll create one simulation project. This is simulation project session 3. Okay, and you can give the author like creative and create. So same as TI portal, you have to create a PLC simulator project here. So it will create a project for you, just act as your simulation project. It's taking some time because this PLC software is very heavy loaded software from Siemens. So this is also project and your simulator PLC is here, but you can see the power is off, so you have to turn on the power for a project. Okay, So for that, what we'll do, we'll select our CPU and minimize this. Okay. Now we'll power on our CPU using the power button. Now CPU is getting on, and you will get your project name here, session 3. Now you can see your CPU is powered on this IP address 192.168.0.1. So now we'll download our project in this PLC simulator. You can minimize the simulator. Okay, I'm minimizing it and select our project PLC and download. Now as you can see, it's getting download in our simulator device. It will compile and create some configurations file, and it's asking for the load. Okay, and it's asking for the start PLC. Okay, I'll select start module and finish. Okay, so loading is completed. Now we'll verify that loading is completed or not. You can see this PLC1, this is our name in project, it has been loaded in PLC simulator here, and PLC is in run mode. Okay, now we can monitor our program by going online. Now PLC, now you can see that PLC is online, and there is another option called the monitor here. You can press monitor, so you can monitor your power flow in your program, in your logic. What is power flow means? Where logic is executing, from where to where, here. So as I said, this is active as your power line, which is showing green. So this switch is open right now, so no power flow is going to the lamp side. So when we'll apply force here, like when we'll apply switch to 1, like when press switch on, the output will be on. So to simulate this I0.0, again we'll open our simulator in expanded view. I'm just minimizing. Okay. Now here there is a sim table. Open sim table. Double click on it, and this is your tag read from your project. So just click on that. Whatever the tag in your project will be loaded in simulator. You can see we have two tags, switch 1 and lamp 1 has been loaded in our project. And by clicking on here bit 1 or 0, your tag will be simulated. So here you can see I am giving the input at I0.0, and you can see the power has been flow to lamp 1. Your NO become NC. NC means your normally open contact now became normally closed contact, and your power supply going to the lamp 1, and your lamp 1 means output is on. Here also you can see the status of your output 0.0, monitor value is true. Now I am switching off the input. Okay, so my output is off. Again my output is on, off, on, off, on, off. So by this way you can verify your program using simulator. Okay, so the next will create a logic for the latching concept. So for the latching, here we will use again switches. For latching there are two buttons. One is start button, which is push button, and this is my lamp 2. So I require 3 input. The address will start from I0.1, I0.2 and Q0.1. So where we'll use the push button where latching is required, like if you want to start your motor by pressing start push button. See, here is not toggle switch, push button. So when I'll press the button, I will get the supply. When I release my push button, my supply will cut. But I have to hold this supply using latching concept. Okay, and uh, my latch will break by stop push button. So for that, again I will use one NO contact for my push button, which is start PB. Okay, and to cut my supply, I will use NC, because NC will use for breaking this line. So I 0.2, which is my stop push button, and this is my lamp 2. Now here you can see that you cannot turn on this lamp by pressing push button, because when you will press the push button, you will get the supply at the lamp 2. But when you release this push button, again you will your lamp 2 would be off. So to hold this lamp status, we have to connect one holding branch of your output contact. So my output contact is Q0.1, so I'll use Q0.1 here. So when I'll press this push button I0.1, I'll get the supply here. And when this coil is on, the contact of this coil, which is NO, will be on here, and you will get the parallel path of your output. So when you will release this push button, but your parallel path having supply, and you will get the output steady on. To cut this holding contact, you have to press the stop push button. You will verify this program using simulator. Just download this program into your PLC simulator. Again, we'll open PLC simulator. We'll update our tag. Okay, it's automatically updated. TI portal is very intelligent software. Okay. Okay, so my tag is updated here. Now I'll press start push button. See, push button is I'll press and release. Okay, I press and release, but still my output is on, because output got the parallel path. Okay, parallel path from the output contact. Now to break this holding, we have to press the stop push button. Now holding is completely broken. Now again, to start the motor or lamp 2, I have to press start button. Okay, this is my press. I'll double click on it. Okay, this is my on, but when I release the push button, my I0.1 will be off. So this is the push button, how we'll use in our program. To cut the latch, again I'll press the stop button. Okay, so for today's session, we have learned how to create a PLC program, basic program. In the next session, we'll learn about some more advanced instructions like timer, counter, and some comparator, and some advanced level instructions. So please like, share and subscribe, and please press on the bell icon so you will get the latest update from our channel.